Here is him, and please welcome Amin.
Thanks, Kyle. I'm probably the most hated person here. I'm the only thing between you and going home, so bear with me. I will try not to take too much of your time. 40 minutes, hopefully we'll be done. But when David told me about this session to talk about at DevFest, I was thinking, what would be a good thing to talk about when, as the last thing of a 2-day event, you're probably already tired, you have heard a lot about different technologies. So I put this together in a way that we can tie things together so you can get started if you haven't been using Google Cloud Platform, so you have something kind of actionable to give it a try. So let's get started. A little bit about me first. I'm Amin. I'm the Director of Technology at AY Technologies, and I've been a software architect and software engineer for over 15 years. I've architected a lot of different solutions on AWS and GCP. And the Google Cloud Platform portion of that is for the past 3 years, since we started using Google Cloud Platform more at AY. And I founded AY Technologies about 3 years ago. At AY, our whole goal is to making the software development process uncomplicated. And we do that for entrepreneurs and startups who want to build successful companies using technology solutions. So anything API, web, or mobile, we usually help them with that, with the goal of creating a recurring revenue model businesses for them. And as Kyle mentioned, we are hiring. So if helping startups and entrepreneurs in Vancouver is something that you care about or you're passionate, check out our job postings on the website. It's aytech.ca. But that's enough about self-promotion. At AY, we've been a Google Cloud partner since January 2016. So if you want to give it a try to Google Cloud Platform and you want to know about the $500 GCP credit to get started, talk to me. If you have a startup or if you work for a startup and you want to know more about the $20,000 credit for startups, talk to me as well after the session or send me an email. But today's presentation, so it's going to be focused on trying to tie together everything that you've been hearing about Google Cloud Platform. So Google Cloud Platform, right now, they have about 75 different services under their terms of service. And they also have a lot more APIs that might not be part of that terms of service, that SLA that they have, but it's part of the platform. So it could be confusing on where to start, which one of these to grab and build something with, or how you can tie the different services together. So what I try to do is to try to answer the question, where should I start? How can I use it for my app or for my startup? Or how can I scale my app on Google Cloud Platform? And for the sake of the presentation, I'm focusing more on a case of building a web application. Although a lot of things that I talk about might be specific to this type of applications or specific to some of the technologies that I use and I try to demo, like Node. It's not only for those platforms or those frameworks, and I try to explain that as well. But let's just start. So I have 7 or 8 different stages that I'm going to go through. I'm going to probably be seated for most of this from now on. But the first piece is about when you're starting with just an idea. So this was the idea that I kind of walk. This was the idea that I had in mind when I was trying to put this together. So would it be nice if I could make all my images files smaller without losing any quality, but just removing the metadata? So that was the idea that I was started with. I didn't want to lose quality. I don't want to deal with servers. It's just something small. I don't want to deal with server or pay for it. So that was my criteria. And then I don't want to deal with the operations. It's just a small API. So how can I do something like this? So let's get started. So for something like this, can you guys hear me? Is that good still? Is it better? Is it good now? Hello? Yes. So for something like this, what we can use is that we can use Cloud Functions. How many of you guys have heard, by show of hands, have heard of Google Cloud Functions or using it? Well, either or, like just show your hands. That's good. So Cloud Functions, you've heard of it. You probably have seen this, so I'm not going to take too much of your time. But Cloud Functions right now supports both Node.js and Python. The Python is in beta. They support Node.js in version 6. The version 8 is in beta as well. My experience using Google Cloud services that are in beta is that they are almost as good as they're in production. Just means that they are not ready to give you the 99.95 SLA on that. So it's usually very safe to even use those in production. I have done that in the past. So don't be don't get discouraged with just the beta beside that. Basically, with Cloud Functions, you can just write your code, push it to Cloud Function, and you're done. So let's have a quick look at what this would look like. For the sake of simplicity, I'm not going to use gcloud command line, but you can always, like for anything that I'm doing today, you can use that. But Google Cloud Functions. So creating Cloud Functions, you log in to your Google Cloud platform. You find Google Cloud Functions. It should be part of the compute portion, and you can, of course, pin them. Creating a new function is as easy as giving it a name. So DevFest. OK, I will do that. Is that better? OK. So DevFest test function. You can decide how many, what's the memory that you can allocate to that. You can go up to 2 gigabytes. And then you can set different types of triggers for this. So the HTTP trigger means that it works like just a HTTP call to that endpoint will be handled by that function. The other types of triggers that you can have pops up. You can create basically use pops up for that. Cloud storage, you can trigger that when a new file is uploaded to a bucket or anything similar to that. There are a few other ones that are related to the Firebase as well that you can use right now. Google Cloud Functions actually is moving a lot faster now with Firebase, and you can use a lot with your mobile apps. Then you can define if you want to use the inline editor that I'm going to show you here, or you can just upload your zip file or just connect it directly to a Google Cloud source repository, which is just Git. When you connect it, whenever you push to that Git, it will be deployed for your Google Cloud Function. As I mentioned, 3 versions, 3 different environments available, Node 6, 8, and Python. It's going to be, let me just show you this. So basically with Node, you have a package.json that you define. So anything that you want, you can add to this package.json. An index, you define your different functions. This one is the hello world. It has a request, has a response, does whatever you want with that, and then you define which function you want to execute. When you have a bigger project, you can have, you have a repository, this function, index.js, could be multiple different functions could be there, and then you define which one of those want to be triggered with which one of those cloud functions that you're creating. So this, as easy as that, and then you're creating a function. A function like that, I have created a few before. Actually, it wasn't working that well this morning, but now it's started working. So that's good for demo. So this is the DevFest scale that I've created before. It's just that similar to the hello world, and you can come and find the trigger. The trigger URL is this. Open that up. I'm scaling up now. So it's like that's as easy as that's how easy you can create a cloud function. So you can create that inside your project and use that. Similar thing is with cloud functions when you want to create a Python project. Run it on a Python environment. You have 2 files, main.py and then requirement text. Similar, you put all your requirements over there. OK, so let's go to the next phase. So now so basically my idea for this was that I have a post endpoint. I post a base64 version of my image to it. It will remove all the metadata. It will send me back the base64 image without the metadata. But so it's nice to have that, and I want to clean it up. But now I want to be able to post back not just the base 64 of the image, but I want to like send back maybe a link to that image. I want to clean that up, send back a link. And I want to be able to share that link with other people. So what can I do now? Now the next thing is that now we can use Google Cloud Storage. So show of hands, how many of you guys have used or know about cloud storage? OK, perfect. So cloud storage is just an object storage. If you are familiar with AWS, cloud storage is similar to putting 5 different AWS services together. So it's the CloudFront, S3 transfer, cross-region replication, Glacier, and S3 all together will become cloud storage. It has 4 different tiers, the multi-regional tier, regional tier, nearline, and cold line. So for example, when you put something in multi-regional, you not only have the S3, but it's also you have the cross-region replication. It handles all of that for you. And like you don't have to deal with anything like that. With Google Cloud, all of those is just something that you select. So I'm going to show you how you can create a new bucket and select these different types of like regions. And then I'll show you how you can use something like that in Cloud Functions. So the next step, Cloud Functions. So let me just go to the storage. OK. So when you go to Google Cloud Storage, let me just make it, it's a little bit more readable now. So you have your buckets. You can create a new bucket. And when you're creating a new bucket, you can decide, is it going to be multi-regional? Is it going to be regional, nearline, or cold line? And it has a definition of like how much it's going to cost for you if it's multi-regional versus regional. The costs are pretty low. So I will not, usually people don't care about these that much unless you have a multi-terabytes or petabytes of data, then it becomes important. But as easy as giving a name, DevFest, test 2018, you have a bucket. One interesting thing about these buckets are the names are unique across all the different buckets in Google Cloud Platform. So it's not just your own project, it's across everything. The name should be unique. OK, so, and then you created that bucket. When you want to use something like that in your Cloud Functions, is as easy as just importing that library into your Cloud Functions. So let's go there. This is an example of like adding just a function and using that there.
It'll stop.
It will stop. That's OK. So just adding a dependency here, Cloud Storage. Like that's, now I can use that in my function, and in my function and just require that. As easy as that, now I can handle Cloud Storage, and I can save things to Cloud Storage from my Cloud Function. OK, I'm going to go a little bit faster because I might be running out of time toward the end of this. OK, so now we had 2 cases. Where am I? OK, let's come back here. So the third stage is that, OK, this is just an API. It's nice, but it's just something that I can use. I cannot share it with other people that much. Like, I cannot give them a really easy-to-use web page or web application to use to maybe have a header, some graphics there, maybe a form there to fetch the file and post it to me. So I want to create a simple web page, but I don't want to deal with server. And I would still want it to look professional. So I want it to come from my own domain name. What can I do now? And as I mentioned, as the cloud storage, it has the Amazon's CloudFront. So it has the CDN in front of it. So we can still just use cloud storage and have all that static website in the cloud storage. So it can. Cloud storage can serve all your static files. We actually use it for all our projects on the web portion of that. All of them are stored and served from cloud storage because it's pretty fast. It can also, if you have a website, you can just serve the whole website from cloud storage. For any static file works. The only thing that you need to do is to map your domain name or subdomain to a CNAME of c.storage.googleapis.com. With this, you have Google Cloud Storage will start serving your website. You can, of course, use your own DNS, or you can use Google Cloud DNS for doing that. But doing that is as easy as, so going to your DNS, setting that DNS name, and then on the GCP side, what you need to do is to create a bucket with a specific name. So if I create test.aytech.ca, then this bucket, whatever is inside that bucket, is going to be served when I put test.aytech.ca in my browser. So I already created one for DevFest here. So you can see this one is called devfest-scale.aytech.ca. And I put in there an index.html file. Let me just create another file. Text edit. Say, this is a test. And I will save that as, let's go to my downloads, test.html. Okay. Doesn't like that. Just delete that. Now I can, so one thing I can show you is that if I go to devfest-scale.aytech.ca, it's the index.html that I have there is getting served. Now if I go /test.html, because the file is not in there, it's going to give me, oh, I don't know this file. What do you want to do with this? So adding that file is as easy as just uploading a file here, test.html. Okay, perfect. And you can see this file is not public, so I need to make that a public file for everybody on the net to have access to that. So I go edit permission, let's add a user. It's called user. Save that. And now this test.html is public. So I can come back here, refresh this page, and the test is there. So anything that you want on a static site, the Google Cloud Storage can handle that, can serve your website. Okay, so with that, I could create my form in there, and then it will work with cloud functions in the back end. I have a full website, it's running all good. That's great. So now I have all of that set up. So the next stage is that, okay, now I have all of this. It's good, nice. But I want to expand from this just one call to something. I want to create a real app. I want to create maybe a RESTful API, maybe GraphQL, whatever I like. And I don't want to just create one-off functions, but I want something that can be operated. I can be like more proud of it if it's an app. And I want it to be still scaled without me dealing with all of that. And when I get more users, I want it to scale. When I get less users, I want it to scale it down without me dealing with the operation side of that. So what can I use now? So for that, we can use App Engine. How many of you guys have heard of App Engine or used App Engine before? Awesome. So App Engine is basically the platform as a service service of Google Cloud Platform that like you just code, you push it to them, they will handle everything from scaling it up, scaling it down, load balancing, they will give you features like traffic splitting, anything like that. They will take care of all of that for you. So if you want to just code and not deal with whatever is operation side of that, this is a great thing. It's probably the oldest piece of Google Cloud Platform. It's like one of those services that it's one of my favorite services as well. It supports Node.js, Ruby, Go, .NET, Java, Python, and PHP. And they have a new version of this that was released about, I think, 2.5 years ago, was in the GA, which is Google, App Engine Flexible, which on that one, basically you can have whatever environment you want yourself, as long as you talk to the port 8080 and serve things. They don't care what you're using. They still will take care of all the different scaling and traffic splitting and all of that for you as well. So that one. So I can show you quickly. Let me see. Not much time. I can show you quickly how it looks like in the back in here when you have one. App Engine, you cannot deploy it via the browser. You need to use gcloud CLI for deploying anything to the App Engine. That's one thing that's good to know. But basically, you can have multiple different services. They can have different versions, and then each version will have one or multiple instances that are auto-scaled automatically by the Google Cloud. And you can, so this one is like a test one that I was deploying when I was dealing with data store. And this is just a data store admin. Automatically, we'll figure out where you want to push those things. You can go and edit the configuration, the number of instances that you want to be, the minimum number of instances that you want to have there, the region that you want to have it. You can control that. It will not work across multiple regions. So that is one of the limitations of the App Engine. If you define it for one region, it will be in that region, and you cannot even change that. In order to be able to change that, you need to create a new project in Google Cloud. OK, so let's continue from here. Now I have my App Engine. I have the APIs, everything working fine. But I want to store my data. I want some data system to be behind this. I want probably a very regular relational database behind this. I'm not a DB admin. I don't want to deal with setting that up or maintaining that or operating that. What can I do now? I don't want to deal with servers either, so just want something that works for me. So let's use Cloud SQL. Cloud SQL is basically your SQL server, could be MySQL or Postgres, in the cloud, managed and maintained by Google Cloud for you. You don't deal with the servers. You don't deal with basically anything maintenance-wise from that. I can just use it. And one of the features that I love about it is something that I have had to deal with before is creating failover replicas for databases. How many of you guys have dealt with that, creating replicas? How painful is that? Could be painful. I'm going to show you how you can do that with Google Cloud Platform. It's basically one click. So this is how you can use Google Cloud's Cloud SQL. OK. So from the menu, you can select SQL, and you can say create instance. You would decide if you want MySQL or Postgres. On the MySQL side, they have 2 generations. Select second generation. And then give it a name. DevFest, DevFest test 2. You can give it a password. Let me just generate something. You would define a region and zone that you want that database to be in. So I can say US West 2. And by the way, for some of you guys that want servers to be in Canada, the North American Northeast one is Montreal. They have almost all the different services that are available in GCP. If you deal with something that's more sensitive and you want it to be specifically in Canada, just choose that. And then you can choose zones and then create. As easy as that, you have your database instance created. So I've created one before, and you can see I have a scale-up DevFest here. And this was the instance that I've created before. You can see all the information about it. It has 1 CPU, 10 gig of storage, 4 gigs of RAM, and I can edit all of that if I want to, or I can just leave it to GCP to give me recommendations. Whenever you overuse your system, GCP will send you a recommendation that this system is overused. Maybe you want to increase the RAM on that, or maybe you want to increase the storage that you have there. But the feature that I was telling you guys about is failover. So adding a failover to my instance here is as easy as clicking on this add and saying what I want to name that failover. And now I have a highly available database with no pain. So that's one other thing that you can do. So this creates the failover replica for that instance. It will, if you already have data in that, it will start to create that replica for you until it's caught up, and then it will keep that just the diff, and it will just push the diff always to that replica. If your main database fails, it will automatically replace that and create a new replica for you. So you don't have to deal with any of that or have anything set up for like monitoring that necessarily, although you can use GCP for that. Okay, so now I have a RESTful API on App Engine, and I have it with the Google Cloud SQL backing, so it stores all my relational database, relational data. But I just had a great idea. I was throwing out all the metadata for my photos so far. Now I'm thinking maybe I want to store those because they will be valuable data for the users in the future. The issue with this metadata is that it's actually not very relational. It's JSON-like, so I don't want to store it in a relational database in a string format. I want somewhere so it can actually traverse through that and like not to have to deal with serializing or deserializing that data. So what can I do with that? I can use Cloud Data Store. How many of you guys have heard of Data Store or used Data Store? Okay. So Data Store is a highly scalable NoSQL database. It's very easy to query. It supports ACID transactions, and you can create different kinds and different types for it, and you can add data, and then you can query that very easily. Okay, I have only 5 minutes. I'm going to quickly show this. Do I have 5 minutes? 10 minutes? 10 minutes, okay. It's good.
It's deprecated, or it's deprecating.
It's getting deprecated with something else that's going to replace it, yeah. With Firestore, but like still going to work the same way. So Data Store, let's find that here. So I've just created a kind of user. You can go and create any entity or any kind that you want, and you can add data to it, and it will just, and then each one of those can have a parent, and it can go from there. And you can easily just give it a schema from JSON format, and it will take that. Then you can start querying that with their GQL. So it's going to be as easy as that. So I'm going to make it a little bit faster from here. OK. Now I'm going to talk about two different ideas. So sometimes, and we have seen these two different paths that the apps take. You release an app, you're successful. You either App Engine is no longer working for you as well as you like it, which is the case at stage 7.1. So your app is becoming more sophisticated. The default App Engine, settings is no longer perfect for you. So what you want is that you want to tweak your system. You want to be able to tweak your system to increase the efficiency, increase the performance. You want to have full control over that. And you can, now you're at that stage that you can take care of your own servers yourself. So what you can use here? Now you can use Compute Engine. This might be the first place that a lot of people get into, those virtual machines. But you can see like there are a lot of things that you can do before you get to getting a virtual machine and dealing with all of that yourself. That might be good to do. How many of you guys have used Compute Engine before? OK, not that many. Let's look at what you can do with Compute Engine very quickly. Compute Engine. So you can create virtual machines. When you want to create a virtual machine, you can just define where it is. You can define which machine type. You can decide from the predefined machine types that are there, or you can just change that or customize that however you want it. Like I can just create this multiple cores, some minimum. Yeah, that's going to be expensive. But like you can create whatever virtual machine that you want. So it's very flexible. But you can also if you know what you want to bring that machine up for, like for example, we have a Jenkins machine that like builds a lot of our apps. So you can just come and find pre-built machines that you can just select and just deploy that. So it's not going to be an empty VM anymore. It's going to be VM pre-built with a specific image. You can create your own images. You can create, and they call it templates as well. It will support snapshots, everything that like regular like AWS EC2 supports. You can do it here and probably a lot more. So another thing that you might get yourself into is that your app actually is getting very successful. And now not only they're using it in North America, but they're also using it in Asia, in Europe. Now just having a single region is not enough for you. So you want to be able to support multi-region and remove that limitations of App Engine, but you still want to be like as separate as possible from the operations of those things. So what can you use here? You can use the Kubernetes engine, which used to be called Container Engine. They just changed the name. How many of you guys have used Kubernetes? Awesome. So this one is migrating from App Engine to Kubernetes is super easy because both of them are based on Docker, and like you can like there are basically codes like 5 lines of code that you can run on your App Engine and extract that for Kubernetes, and you can basically get all the goodness of Kubernetes to your app that you've built with App Engine. So that's something that we've seen be done a lot. Okay, I want to give you guys a few minutes to look at. But Kubernetes basically is a fully managed Kubernetes cluster that will have auto-scaling, auto-upgrade, auto-repair, and the network spans over multi-regions and zones. But to recap, I think I want to keep like 5 minutes for questions. So no matter which stage you're at, you can get started with GCP, and that's the whole point here. You can be just starting with one single API, or you can be just moving the whole Kubernetes cluster to GCP. You can do that. You can just decide to do that. But basically, you should use GCP if you want to save time and focus on your core business rather than operation. Also, it could be an iterative process. So just do it in small incremental steps. Don't try to dive full force into it. Just do it piece by piece. And then usually we've seen the best results when it's done that way. And that was a very fast recap. So sorry about that. I hope that it wasn't as boring as it might have felt to me. But with that, I think I have a few minutes for questions. I've heard that early next year, that's what they have planned to bring it into beta. Don't quote me on that, because it might things might change. They will not release it until they are ready to do that, of course. Yeah. But the question was, I did not repeat that, is that when the scheduler for Cloud Functions might be released. Yeah. Okay.
Based on your experience with AWS and Google Cloud, how much cheaper is Google Cloud compared to AWS?
If you compare try to compare apples to apples, approximately about 57 to 60% cheaper. So it's a significant amount. It's a significant portion. But also you can get a lot of credits to get started with GCP as well. So, and if you're coming from AWS, it's easier to get those credits as well because they want you to migrate. Yeah.
So you can run Kubernetes on your PC, using Minikube and put that to the cloud. Is there some open source environment that you're aware that you can use serverless on your PC and then just push that to the cloud?
So serverless on your PC, is there any environment that you can use serverless on your PC for sake of development and then when you're ready to push that? There is an emulator for Google Cloud that you can just run locally. It will basically, you'll have your endpoint gonna be on localhost / something, and then you can build it there, and then whenever you're ready, you can push the code to the cloud. So it's called Google Cloud Emulator. It's part of the G Cloud suite, so you can easily get that. Yeah, and they are changing a few things in there and getting better. Like it's actually a really good emulator.
You just talked at data store. They said it's deprecated. So what do you replace that?
Firestore is replacing that right now. It's basically something that's like, don't know exactly the difference behind the scene, but like it's coming from the Firebase suite of things. It's coming to Google Cloud. They're trying to integrate all the things that we got from Firebase with Google Cloud more right now.
You can run it in data store mode. It's fully compatible, but it's all completely different behind the scenes there.
Yeah.
The actual infrastructure.
Yeah.
Following question, what's underneath of the data store? What's technology used behind their data store?
I actually don't know what they're using underneath that. That's the question. Anybody knows what they're using underneath the data store? What's the technology? But this is the thing. From the development perspective, you don't care like what they're doing. As long as they maintain everything the way that they're doing it right now, you don't care about that. Yeah. Any other questions? Okay, I think we're good. Thanks.